Hello, ladies and gentlemen. Welcome to my channel. I'm Raju Pujala. In this video, let's take a look at logistic regression. If you're following all of my videos in this playlist, I have already covered how to use the random forest classifier and linear SVC. And we have compared these two models. And now let's take a look at logistic regression and let's see how this performs. Cool. I'm so excited to walk you through on how this logistic regression works. I'm not going in depth of these models because I would like to show you what are the different types of models like. And then once I complete all the basics and once you're comfortable, then I will take you in that what are all the differences between the logistic regression and a random forest classifier, when to use that, when to use this, or like if you don't know all this, and what is the best way of how to run everything in one go. Okay, cool. Let's quickly jump in and see. Okay, I'm following this recap collab over here. So again, I would like to start everything from beginning. So if you're a beginner, let's import the data. So I have imported the data here for the dataset path. Look at the description in my YouTube channel as PD and df is equal to pd dot read csv. Okay, and I would like to have low memory is equal to false. So guys, I have been doing these videos on weekends and weekdays like early morning. So please do like and subscribe my videos if you like the content. If you wanna see this one, I have already performed the EDA explore data analysis on this one, so I don't want to again spend time on this one. Let's These are all the features from age until the tal, and the target is the label. So let's split access the features is equal to df dot drop. So this is the one. Columns is equal to, so axis is equal to 1 because this is the columns we're giving, and y is equal to df of this one. I'm writing the same code again and again. So what I'm trying to tell you over here is that, guys, please do practice again and again and again as much as you can. So that's how actually you can be expertise in this one. I'm splitting the data. Okay, and import numpy as np. I have already covered all of these in my previous videos. Please do watch. So xtest y trying y test is equal to, I'm sure that I'm going to make more than like some 150 to 200 videos on machine learning, guys. So please do watch my channel, all the videos. You know what, so there are like so many concepts on machine learning, and and it took me whole 2 years, but you know follow my channel, I will explain everything very nicely, I hope. So it's very important to check after splitting whether the split happened properly or not, or else you have to spend time on Gemini, ChatGPT to debug the errors. Okay, now we have split the data. Let's do with the logistic regression. So from sklearn dot linear model, import logistic regression. We are doing the classification, and you might get a doubt that why we are using the regression model here. So basically, this is how the logistic regression looks like. So if you see here, so this is a sigmoid curve, S shape. Here, for example, 0 and 1s, or like A, S or no, or A or B, something like that. If you see this one, the logistic regression, because the curve, it looks like sigmoid, it's a regressive curve. So that's the reason they call this a regression, logistic regression. But this is a linear model, um, classification model. This is only used for the classification. Just do remember that. It's very much important. So don't get confused. So I'm calling this as LR is equal to logistic um, regression. So we already let's fit the data, X train, Y train, and let's run this one. Okay, this is like completed. The training has been completed. Hey, this is like so easy. If you see all the videos, it's not that hectic to write a code to train the models. It's like simple 2 or 3 lines of code, right? So let's look at the score of X train, Y train. This is like 84 percentage. But if you remember the random forest one, X train, Y train, it is like 100%. So now, guys, you decide whether you want to use with the logistic regression or the random forest. But again, I'm not trying to say that random forest is the best model for each and every time. So you have to use multiple models at a time to understand which one suits for your data set. So now RF, sorry, logistic regression test score is equal to um, LR dot um, score X test Y test. So print this one. Let's print this one, and let's see what is the score. It is 80 percentage. So we already have seen the linear SVC and the random forest. Let's plot everything here. Huh? Um, okay. So PD dot data frame data is equal to RF random forest test score is equal to random forest test score. This is a score. I mean, if you are watching my previous videos, you will understand this one quickly. SVC test score. So this one here and logistic regression test score, or I can do like random forest. Okay, this is SVC and this is logistic regression to look it neat and clear. Because all of this thing has individual values, we have to pass an index. Index is equal to accuracies. Okay, so SVC test. Okay, spelling mistake. My apologies. Okay, you can see that random forest score is like, okay, you can multiply into 100, 83, and then I would like to have like this one. So okay, so this is 83. Let's multiply into 100, and let's multiply here as well into 100. Okay, so random forest is 83 percentage, whereas SPC is 80, and the logistic regression is also 80. If in case if you want to plot this one, plot kind is equal to bar. Um, you can see that random forest is the winner here, and SVC and both logistic regression have performed equally well. But if you see, if you, I mean, by looking at this graph, if someone asks like which one you want to go ahead, you can go ahead with the random forest. If you don't want to show this axis, you can mention like plot dot show. I'm not sure whether it will work here. Yeah, there it go. Right. So in our case, for this data set, random forest is the true winner. Right. So this is the end of this video on how you can use the logistic regression. And when it comes to the predictions, it's quite common for any model. For example, y predictions is equal to, for logistic regression, what we said, LR, right? LR dot predict X test and the Y preds, and it does the predictions over here. So the rest everything is same, only the kind of model that you are choosing is a different. Okay, so thank you for watching this video. One thing, guys, this logistic regression, it takes like lots of time usually if you have like more data, and that's one of the disadvantages. But this performs quite well. Thank you for watching this video. In my next upcoming video, I'm going to run all random forest classifier, um, linear SPC, or instead of linear SPC, let's okay, linear SPC, and let's run like one more neighbors model and the logistic regression, and see how we can run multiple ML models at a time. Thank you for watching this video.